Okay, so hello everyone. My name is Kunal, and I'm your mathematics tutor. And we are actually doing definite integration. And today is our lecture number 7. Okay, so today is our lecture number 7 in a definite part. So let me recap on what have we done till now. So we actually know the geometrical interpretation of definite property, volleys, right? And king's rule, queen's rule, odd even. And yesterday we saw some property. So let me write here, and I actually proved one. So let me prove each and every single property out of 5. So let me write here once, and then we start proving each and all, and then learn how to implement those property in given integral. So let me rewrite the property that we learned in last class. And so we also learn its proof, like how to prove it. So these are the property 4. So let me write here. Our first property जो कि हमने प्रूव करा था, इसकी कंडीशन थी जो मैंने बताया था कि fx must be a periodic function. And you know that what is periodic function. Basically, a periodic function means like f of x plus k is equal to f of x for some k, where k belongs to some integer. So like our k is the period. So fx must be a periodic function uh, with, uh, with a period t. We are assuming that its period is t. So this is the condition. And what's our first formula? When we are integrating from 0 to nt fx dx, what we are getting n times and multiplying in just one period. So actually हमने इसकी proof previous class में देख रखी है. Now we are going through the second property, which is actually mt to nt fx dx, which is equal to n minus m, and we are integrating from 0 to t fx dx. I hope you'll all understand this, what I'm trying to say. Now the third property, which is something look like we are integrating from a to a plus t fx dx, which is actually equal to 0 to t fx dx. And then our d property with something look like we are integrating from a to a plus nt. This thing I discussed in previous class, but proof हमने देखी नहीं थी. So in today's lecture, we go through it, them all proof. Like how to prove these property is important for board's perspective, maybe, and belongs to y. And the last property will something look like we are integrating from a plus nt to b plus nt fx dx. This is very rarely used property, the last one. So we are integrating from a to b fx dx. Okay. So now let me prove, like we already proved the a part. So let's move to the proof of b part. So let me prove the b part here. So what is our integrand? Our integrand saying, if you go to the b part, okay, we are integrating from mt to nt. That means our lower limit is m times period t, and the upper limit is n times of period t. So our fx dx is equal to where n and m given is belongs to integer, right? So let x is equal to z plus mt. We use this substitution. So when we substitute this, what we get? We are getting I is equal to, let me show you the limit variation. Okay, then we go through there. So let me show you actually the limit variation. So limit variation. So when x value empty, that means for lower limit. So the value of t will be here. If we look here, what we get, the value of t. So when x value is empty, so will be like empty is equal to z plus empty. So the value of z will be 0, right? Because this empty get cancelled. When x value is equal to empty, this is for actually lower limit. So let me write here. This is for lower limit and this is for upper limit. So nt is equal to z plus mt. So we get n minus m into t is equal to z. So this is my z lower limit and this is my z upper limit. So let me rewrite our integral. So our integral now look like we are integrating from 0 to n minus m times of t, and our fx look like something z plus mt and dz. I hope you'll all understand is what I'm trying to say. Actually this value is automatically equal to, they are integrating from 0 to n minus m into t and f of z dz, and this is equal to, and we know that applying property 1 here, applying property 4 part A. So what we get here, n minus m 0 to t, and we can, this is z is variable, so we can write into any form. So fx dx. This is our simple proof, right? I hope you'll all understand this, what I'm trying to say, right? So let me recap you what I done here. So we have to prove that this part is equal to, we have to prove that this part is equal to, let me write here. This part is equal to, we are integrating from n minus m times 0 to t fx dx. So what I do here simple substitution. What I substitute here, then I just substitute x is equal to z plus mt. Okay, I just substitute x is equal to z plus mt, and then I see the limit variation according to our substitution. So we got the lower limit is 0 and the upper limit is equal to n minus m times of t. And then I rewrite my integrand. So our integrand something look like, we just replace x by z plus mt. So our integrand look like in this form, and then we get to the final result, which will be favorable to us. Now let's move to the proof of the third part. So our what we have to prove in part third. So we have to prove that like we are integrating from a to a plus t, fx dx is equal to, we are integrating from 0 to t fx dx. I hope you'll all understand the previous one. So let me rewrite this problem. Okay. So since we know that fx is continuous in a to a plus t, in x belongs to a to a plus t. So what I'm going to use here, I'm just going to use here a simple property, which is looking like a to t fx dx plus we are integrating here from t to a plus t fx dx, right? So I'm just uh, broke into our given integral into two part. Okay. And then what you try to do here, in second part, let me rewrite clearly. Okay. So what I'm trying to do here, I just break this integral into two part as our axis continuous in a to a plus t. So let me break it into two part, a to t first, fx dx, and then t to a plus t, fx dx. Okay. Now, what I have to do here, let's substitute in this part. x is equal to z plus t, right? What you have to do, just you have to substitute x is equal to z plus t. Okay. So when you do that, so let's this part of integration as I dash. So let me rewrite here. Our I dash is equal to, we are integrating from t to a plus t fx dx. And now what I'm trying to do, I just here substitute x is equal to z plus t, right? This is our substitution. Now, try to see our limit variation here, right? Let me see here the limit variation in I dash according to z. So let me write here x lower is equal to t. So t is equal to z plus t. So the z lower value, that means z lower limit is also 0. Now x upper. So the x upper limit will be like a plus t. So a plus t is equal to z plus t. So it get cancelled. So the z upper limit. So the z upper limit is nothing but a. Okay. I hope you'll all understand is what I'm trying to say. So implies our I dash look like we are rewriting our integrand. So our integrand something look like we are integrating from 0 to a f of z plus t dz. And we know that the function is periodic. So uh, it is equal to f of z dz, right? Now let's move on to our original integrand. What is our original integrand? Will look like 0 to a. We can also rewrite this as 0 to a fx dx, right? Because variable can be anything now. So 0 to a fx dx. I think I do simple mistake here. There will be like a to t fx dx plus 0 to a fx dx and okay, 0 to a fx dx. So what we can write it here? We can write it here this as 0 to t fx to the power. I hope you'll all understand this, what I'm trying to say. If not, then let me rewrite here. What I'm trying to do here, like 0 to a fx dx, this part here written, plus a to t fx dx, and the both function is continuous in, right, in 0 to t. So be using the property that we read in our lecture number 1. So we can write it into like 0 to t fx dx. I hope it will be clear to you. Now let's move to the proof of the property D. It is actually saying we are integrating from a to a plus nt fx dx. So it will be equal to something like 0 to nt uh, f of x dx, right? So we are just using the previous property, so it will be directly written into one line. So its proof is, let me rewrite here, use the property for E, right? Fourth C. So it will be directly proved to the that part. Okay. So let me move to teach you its implementation, like how to implement those property. So let's begin with some example. Okay, so let me rewrite here example or problem number 1. So these are the property that you have to implement in the given integral. Our question number 1 will something look like we are integrating from 0 to 100, and our given function look like 3 to the power x divided by 3 to the power box x. Okay, let me 3 to the power box x. And you know that the box of x is what it represents? Greatest integer function, right? Greatest integer function it represents. That means actually you read this thing in chapter function, which will be taught you in before the definite part somewhere. So you know that what its function and how it implemented. So we're not going through the function chapter. We just, I assume that you know the box of X function implementation, how to implement it and rule. So let's move on to that and answer. Okay. So we know that we can write by using a simple exponential property as x minus box of x dx, right? And we know that x minus box of x is nothing but fractional part of x. So 0 to 100, 3 to the power fractional part of x. So we know that the function of the fractional part is, I have the period 1. This is 0 to 1. This is 2, right? It has period 1. So the period of function fractional part of x has period is equal to 1, right? Its period is 1. I hope you will understand this, because after each x is equal to 1, the graph is repeating. So its period is 1. So now we are trying to use our property number 4a. Using property fourth part A. So what is the property fourth A? Actually, it is integrating from 0 to n(t) fx dx, which is equal to n times of 0 to t fx dx. I hope you will remember this property. So let me rewrite here our integrand. So my integrand is something look like 0 to 100, 3 to the power fractional part of x, or into dx. So what I have to do here, we have to write like 100 into 1. So this is our n value. And this is our period, 3 to the power x dx from 0. So what I'm gonna, in next step, we are integrating from 0 to 1, 3 to the power x dx. And we know that in 0 to 1, fractional part of x is equal to x. So we are integrating in 0 to 1, 3 to the power x dx. And we know the integration of a to the power x is a to the power x by ln a. This thing are taught in actually indefinite integration first lecture. So if you have any problem like how I using this, so go through the indefinite integration lecture number 1, in which I taught you this. So 3 to the power x by ln 3, and let me substitute the limit. So insert the limit here, what you get, 3 to the power 1 by ln 3 minus, when you put here 0, it will be like 1 by ln 3. So you get the value as final answer, 200 by ln 3. So this is my final answer. I hope you'll all understand this, what I'm trying to say. So let me tell you again what I'm doing here. So our given integrand is something look like, okay, so our given integrand is something look like 3 to the power x by 3 to the power box of x. And we know that the box of x function represent the greatest integer function. Basically, it represent an integer. And I assume that you already learned this thing in function chapter. So I'm not going much detail in defining the box of x function. So we know that we are using a simple exponential property, which is like a to the power m by a to the power n is equal to a to the power m minus n. So by using that property, what we get? We get our integrand look like 3 to the power x minus box of x, right? But what we get? 3 to the power x minus box of x. And we know that the x minus box of x, x minus box of x is something look like fractional part of x, right? It's 3 to the power fractional part of x, and the fractional part of x period is 1. So how I get the fractional part of x period 1? So when I draw the graph of fractional part of x function, so this is our graph of fractional part of x, actually. Graph of fractional part of x. I hope you'll all the how to make graph is already you learned in chapter function, so I'm not going in much detail here. So this is the graph of fractional part of x. So the period is 1. And now from here you have to learn that how to implement the property 4. So I'm using the property 4th A, which is this one actually. So let me show you. Okay, so I'm using this property here. So I rewrite the equation. So our n value here is 100, right? Our n value is 100 here. So the n value is 100 here, and then what I'm trying to show, here is basically using property 4a by like integrating from 0 to 1, and we know that in 0 to 1 our fractional part of x is equal to x, right? Fractional part of x is equal to x. So we are just writing fractional part of x as x, and we integrate the following things and we get the favorable result. Whatever we get, this is our answer, right? So okay, let me rewrite the second problem and move on to the second problem. So our problem is look like, okay, so you have to just learn the property and how to implement it, because in definite integration एग्जाम में मैक्सिमम क्वेश्चन प्रॉपर्टी पे ही आनी है, ठीक है? प्रॉपर्टी बेस्ड क्वेश्चन बहुत आती है एग्जाम में. So you have to actually learn how to implement those property. Okay, so okay, let me rewrite the question number 2. We are integrating from 0 to 10 pi root under 1 minus cos square 2x dx. Right, we are integrating from 0 to 10 pi. Okay, and we know that 1 minus cos square x is equal to sin square x. So it will be like mod of sin x, right? Because it gives the positive value. So we are just using that. So let me rewrite it. So we are integrating from 0 to 10 pi. And here our function is mod of sin 2x dx. I hope you'll all know that the period of function. See, we are using the concept of chapter function here. So if you have any problem that in understanding this thing, that means you have some problem to understand the topic in function. So you have to go through it once and then try to understand this thing, right? If you are facing any kind of problem here. So the period of function mod of sin x or cos x, mod of cos x will be pi. And we are using the concept of like the function of sine f of ax plus b is nothing but period of by mod of a. So we are using the same concept here. So the period of function sine mod of sine 2x will be, the mod sin x function will be pi. But here the of the form ax plus b, right? Let me rewrite here. So our function is the form of like f ax plus b. So it will be like a value is 2. So our period is pi by 2. So what I have to do here now? Let me rewrite the integrand. So our integrand look like we are integrating from 0 to 10 pi mod of sine 2x dx. So we can write it into like 20 into pi by 2. And this is our period. So it will be written into anti-form, right? And sine of 2x, mod of sine of 2x dx. And here is 0. So this integrand of the form like 0 to nt f of x dx. So we know that its integration is n times 0 to t fx dx. This is nothing but property 4a. So we are applying property 4a here. And so we are getting 20, 0 to pi by 2 mod of sine 2x and dx. Now let me draw the graph of sine 2x here. So this is the graph of, actually there will be 0, this is pi, and this is 2 pi. But here, so this is pi and this is pi by 2, so this is pi. So therefore, in 0 to pi region, so in 0 to pi region, pi by 2, our graph is positive. Our sine 2x value is positive. This is actually the graph of y is equal to sine 2x. Okay, y is equal to sine 2x. So in 0 to pi by 2, its value will be positive, and we know the property of mod, like it is mod of x if x is positive, and minus x if x is negative. We know that, so we are using the same concept here, and we actually see from graph, look from graph, like in 0 to pi by 2, our sine 2x value is positive. So what I do here, our mod open with the positive sign. So 0 to pi by 2, we are integrating sine of 2x. Yes, you do now what you have to do. So we know the integration of sine 2x will be nothing but minus of cos 2x by 2. Right? And just substitute the limit here. So it will be like 10 and the pi by 2. The cos pi is actually minus 1. So it will be 1 plus 1. Just insert the limit here. So you automatically get that the answer will be 20. Right? Okay, so I hope you'll all understand this, what I'm trying to say. Now let's move on to the next problem, which is something look like we are integrating. This is problem number 4 or 3, whatever. We are integrating from 0 to 2 pi, and there is the function our cos cube x dx. So look, we have to find the first period of the function mod of cos cube x, right? This is our first work. And then we can apply something different here and do the whatever integrand asked. So let me write here one thing. So now let's move on to the period of the function. What is our function? Our function is nothing but mod of cos cube x. And we know that, what like mod of cos x, mod of sin x, function period is nothing but pi. So here we also get the period of the function cos cube x is pi. Okay, so we know the value of t now, right? Its function is pi. Now what I'm trying to say here, this function is again in the form of 0 to nt f of x dx. So we can write into nt 0 to t f of x dx. Now we are using property 4a. Okay, so our 0 to 2 pi cos cube x dx will be equal to 0 to pi mod of cos cube x. Let me rewrite here. Mod of cos cube x dx into 2 times. Right. And next, what you can do, let's apply Quinn's rule here. Applying Quinn's rule here. We know that in Quinn's rule क्या होती है, ये जो लिमिट है वो आधी हो जाती है. So let's do that. So it will be like 0 to pi by 2 f of x plus f of 2a minus x. I mean pi minus x, right? So it will also appear as a positive. So what we get overall here, like 4 times of 0 to pi by 2 cos cube x dx. Here again we get the cos cube x, right? No harm in doing this. Okay. So it will be something look like that. Now what you have to do? Now we get the result as 4 times of 0 to pi by 2 cos cube x dx. So now apply Wallis here. Wallis formula, because we are integrate this integration of the form of cos to the power nx dx, and we are also integrating from 0 to pi by 2. So this integration is actually favor to apply Wallis here. Okay. I hope you'll all understand this, what I'm trying to say. This integration favored to apply Wallis theorem. Why? Question is why? So because it's integrating from 0 to pi by 2, and it is also of the form cos to the power nx. So it's favored to apply the Wallis theorem here. So let me apply here Wallis. So here n is equal to 3, which is an odd. So we have to multiply it by 1. So let me rewrite it. So 4 into 3, we are subtracting 1, and then 1, 1, then multiply, right? So we will get the following answer as 8 by 3. So this is our following answer of the given integrand. I hope this thing is clear to you, right? Okay. Now we actually going to the next part. Okay. So now let's take the another example, which is something look like this is actually important. So you have to look it into very carefully. Which is our question, so that this is important question. You have to understand it very carefully. So here, because their limit is not written in form of direct format, so we have to integrate mod of cos x dx from 0 to n pi plus b, where actually v is varying from pi by 2 to pi, right? Where v is varying from pi by 2 to pi. And actually belongs to natural number, which is equal to 2n plus 2 minus sine of b. Now you have to find the uh, integration of this integrand. So actually this question looks unfavorable because it's written in some uh, condition as well, and written in word as well. So let me try to break this question into smaller section so that you can understand this problem in a well manner. So what I'm doing here, first read the question. Okay. So actually we have to show these things are actually condition, but if you go through the final part, so we have to actually prove here. And what we have to prove? We have to prove like, okay, we have to prove like when we are integrating from 0 to n pi plus v plus cos of x dx. So it will be equal to actually nothing but 2n plus 2 minus sine of v. So this thing you have to prove it here. Now pause the video and think like how to approach this problem. Let me give you a hint. So we are using the property that which we read in the previous class और जिसकी आज हमने proof भी देखी है. So you have to use the those simple property. Okay, so like how to approach this problem. So so pause the video and try to solve it by own, and then you look to the solution. So that will be more effective to you. I'm giving you a hint, which is like we are using the property 4. I'm not gonna tell you the section because it's gonna easy to you. 4A, B, C, D, any of them, right? You have to select the part which property I'm gonna use here. So pause the video and try to solve. So I'm gonna solve that. Let me prove here. So first we know that our fx is continuous in x belongs to 0 to nv and pi plus v because we are integrating this function. And we know that the definite integration is only defined if our x is uh, continuous in from lower limit to upper limit. Okay, the function should be continuous. So, okay, let me break this given integrand into two parts, which look like such as we are integrating from 0 to v mod of cos x dx plus b to n pi plus b cos x dx. Right, we can do this thing now. And then again do one thing. Let me rewrite here so you can understand what I'm trying to say. Uh, Again, break it into two parts, which is something look like we are integrating from 0 to pi by 2 mod of cos x dx plus pi by 2 to v mod of cos x dx and plus right like v2 and pi plus v. We can do this thing, right? Because our function is continuous. So we are using the property which we already read in lecture number 1. So if you not understand what I'm doing here, so go through the lecture number 1 and watch the property carefully. Okay, so now let me open the mod here. So what we get, if you know the graph of cos x, y is equal to cos x. So how it is looking? It's something look like that. This is 0, this is pi by 2, this is 3 pi by 2. Okay. So in the region 0 to pi by 2, our graph is positive. Look at this section. Look at this section. Our graph is positive. So in this section, our mod open with the positive sign. So we are writing like 0 to pi by 2 cos of x dx and plus pi by 2 to any region, pi by 2 to any region, something like I'm telling you v, the value is negative. So it's open with the negative sign. So pi by 2 to v minus cos of x dx and plus 0 to n pi. We are using the property 4D here for this, right? A to A plus and D. Let me rewrite here what I'm using. Like we are integrating from A to A plus and T. And we know the period of the function. Let me rewrite here. Period of mod of cos x is nothing but pi. Okay, you have to know that. So we are using this property, so we can rewrite it into fx dx as 0 to anti fx dx, right? So I am just doing that. So it will be open through the cos x dx, right? It will be like mod of cos x. We can't assume that how to write this. So its integration will be sin x. We are inserting the limit here. It's also integration will be minus sin x. So it will be like minus sin x. We are integrating pi by 2 and v here. Now look at this part. We are now applying the property 4a here because this equation is similar to fx 0 to nt dx. So we know that set integration will be n times of 0 to t fx dx, right? Okay. So I'm using the property 4a. So let me rewrite here. I'm again uh, recap you like how to do, but first try to understand what I'm doing here. So let me apply the property 4a here. So what we get, we have to integrate from 0 to pi mod of cos x dx. So let me solve here. So here we get 1 minus sine of v, inserting that, and then we get plus 1, and here we get plus n times 2. So what we get from here? 2n plus 2 minus sine v. And this is our, we have to, oh, let me erase and rewrite with a good math. So this we have to actually prove. So this is not a single property based question. We are actually using the combination of the property. Like first we are using the 4D and then we using the 4A. Okay, so let me tell you again what I'm doing here. Okay, so actually we are using the concept of the lecture number 1, the basic part. When we integrate and when we substitute the limit in integrate. So the condition is the function should be continuous in uh, between x lower limit to upper limit. So I'm using that property here. So since the function is continuous, so we can write, we are first integrating from 0 to v and then v to n pi plus v. Then we can also write it into 0 to v as 0 to pi by 2 and pi by 2 to v and then v to n pi plus v. Okay, and so we integrate this problem, but now in the last of the integrand, which is we are integrating from v to n pi plus v, this is of the form of like 4D, property 4D, where something look like we are integrating from 0 to a plus nt, right? We are integrating from a to a plus nt. Then what we have to do, we are applying here the property 4D. So it get converted into 0 to n pi cos x dx. So now this is again in the form of like property 4a. So when we apply the property 4a here, what we get? We get the favorable result, which we'll have to prove in. I hope you'll all understand this, what I'm trying to say, right? So, okay. Now, let's move on to the one more problem. Then we actually, we will move to the next topic, which is Leibniz integration. What is it? It's proof and all thing we look in next class. But for now, we are learning some more approach to solve the problem. So let me take you a basic example, which is something look like complicated, and then we solve that problem. So today's last problem, which is something look like we are integrating from pi by 3 to 13 pi by 3. And we are actually integrating mod of sin x dx. Okay, so what its value? So I'm again telling you, pause the video and try to solve by using property 4a, b, c, d, e. Right? इन्हीं पांचों में से तो कोई एक प्रॉपर्टी यूज हो रही है. That's it. We first let me solve you. So you pause the video and solve the it by own and then go through the solution. This is my suggestion. So the period of mod of sin x will nothing but pi. So we get the value of t here. Now here written as something like a A is equal to pi by 3. So we can convert this into like A plus NT, right? So how to do that? So we can write as pi by 3 plus 4 pi, right? Here the value of N is 4. So we can write 13 pi by 3 as 4 pi plus pi by 3. So what is it? A to A plus NT form now. And this is our nothing but property 4C. So when we apply the property 4C here, what we get? We have to just integrate from 0 to NT here, fx dx. And this, when we apply the property 4A, look what I'm doing. I'm not solving at all. I am just implementing the property. Solution will get automatically as in a final result. I'm not solving, like I'm nothing substituting here, nothing doing. I'm just what I'm doing. I'm just substituting the result, substituting the property, implementing the property. Now we are, this form is equal to part 4A. So we get n times 0 to t mod of sin x dx, which is equal to n is here 4. We are integrating from 0 to pi sin x dx, right? I hope you'll all understand this, what I'm trying to say. So it will be mod of sin x dx. And let's draw the graph of sin x here. So the sin x is, the sin x graph is something look like that. This is 0, this is pi, this is 2 pi. Look at here. Sin x is positive in 0 to pi, right? Sin x is positive in 0 to pi. Okay, so sin x is positive in 0 to pi. So this mod is open with the positive sign. So 4 times of 0 to pi sin of x dx. And we know the integration of sin x is minus cos x, 0 to pi 4 times. And this integration value is 2. So we get the final answer as 8. So you have to learn like how to implement property. देखो मैं यहाँ से लेकर के यहाँ तक कुछ भी solve नहीं करा है मैंने. I am just implementing the property, do some manipulation, some simplification, and just implementing the property in this region and in this region. I'm not solving anything. I'm just implementing the property in this region. In just last step, I do the integration. Okay. So you have to learn like how to implement those property here. Solve to last एक step में ही हो रही होगी. But you have to learn like how to implement the thing. If you will go through the problem, मैंने यहाँ से लेकर के यहाँ तक कुछ भी solve नहीं करा है. I'm just implementing the property. In last step, in these 2 steps, I draw the graph and try to see like mod is open with the positive or the negative sign. So we get the mod is opening with the positive sign because in 0 to pi, the value of sin x is positive. And then I just do the integration and we get the final result. Okay, so that's all for today. In tomorrow class, we will deal with Leibniz integration. This is actually very much important. And then we go through the sum of infinite series. Okay, so this thing we learn in the upcoming days. So don't worry much and try to focus on what we do here and how to implement the properties and all. So that's all for today. Thank you.